Hi gents, welcome to our first online lesson. Really today is just a proof of concept just to see is this going to work out, is this a good format for you? We've been told to do live online classes at the exact time of our maths lesson, but I think it's just much more useful to have a recorded video. You can stop me, you can pause me, you can try stuff yourself. And then you can email me questions if you have them. I think that's just a much better way to do it. But obviously, let me know what you think would be most useful as we go along with it. What I'll do is I'll do a particular question. This is 2017 paper 2 question 5. So the way that you should use this video is you should take out your past papers and actually try this question first. Don't just have me reading through the question and just doing it for you. That's as useful as for getting fit as it is just watching an exercise video. So you may as well actually interact with it. So pause me at the beginning, give it a shot. And then if you can't do it, you can come back to me, or if you're looking at the way that I did it, you can come back to me again. And even if you weren't able to do it the first time, you can pause me partway through, if I've nudged you towards an idea or something like that, and give it a shot from there. Okay, we're going to do geometry because we haven't done much geometry. It's basically really just junior cert without too much extra stuff inside of it, and certainly the one today doesn't have too much extra stuff. Now, the junior cert was, close to 3 years ago, so it's understandable that you might have forgotten some of it. So we'll just go through it as best we can. First question here in question 5 is prove that triangle AFE, so AFE, right angle triangle there, and DAE are similar triangles. What does it mean to be similar? Just means that all three angles are the same. It's not the case that all the sides have to be the same. That would be congruent triangles. So this one, you're just trying to show that all three angles, I beg your pardon, are the same. It does mean that the sides will be in proportion, but we'll get onto that a little bit later. So if you use the words, the term or word proof, which is going to have to be quite rigorous about it. Okay, you don't just say one thing equals the other thing. You got to say why that one thing equals the other thing. So obviously, if we're trying to show that all three angles are the same, we should start off by saying this angle equals that angle and why that is the case. So we'll start off doing that, and I suppose the most obvious one really is to say that angle from A to E to F, that's the right angle that was given to us, is equal to angle A. Let's try that again. A to E, and that's all the way over to D. Why is that the case? Well, obviously what we have here is we've got a vertically opposite angle, but you can also say that this one is simply a right angle because you're dealing with a straight angle. So this one, it's a little bit tricky to know what to write down. I guess I would say that they're both 90 degrees, and if I was really going on overkill, I would just say that, what would we say? We might say that FD, that line FD creates a straight angle. Straight angle being 180 degrees. So if we were to do 180 minus the original 90, that would be 90. That's probably overkill, but look, it's your leaving cert, so why not just write it in, I guess. So that's the first thing. Of course, we're going to have to come up with three things. We're going to have to say this angle equals that angle, the other angle equals the other angle, and the remaining angle equals the remaining angle. So which one is which? I guess we've got a choice here. If we look up and kind of zoom in on this particular thing here, I'll just change our color here and just have a look at it. What are we really saying here? We're trying to show that this angle here, just reduce the font size. Okay, we're trying to say that that angle there, I guess we're trying to say that that will be the same as that one. And we're trying to say that the angle here, maybe put a double one around it, is equal to this angle there. That's what it looks like. So really, let's just try and do that last one. We'll try and say that beta is equal to gamma. And what we'll do here is we'll just over to the side maybe write out a little proof of it. Definitely this is a part where you want to pause the video and have a shot at this yourself. and just see can you manage it yourself. But anyway, here goes. I'll just do it over to the side and we'll go from there. Okay, one thing that we can definitely say, alpha plus beta plus 90 is equal to 180. It's obviously 3 angles in a triangle. 3 angles in a triangle. It's obvious, so therefore it must be that alpha plus beta is equal to 90 degrees by taking 90 away from both sides. Okay, that's fine. And here's the next trick. The next trick is to say that also alpha plus gamma must be 90. Why? It is, of course, a vertex on a rectangle. We're dealing with a rectangle, so it must be 90 degrees. Okay, well, if alpha plus beta is 90 and alpha plus gamma is 90, it follows that alpha plus beta must equal to alpha plus gamma, since they're both 90. And if we take alpha away from both sides, we do get that beta is equal to gamma. So it's just a nice little proof that that is the case. So what can we say now in terms of our triangle? If we just go back, what we can say now is that, what did we just get? We just got that angle. AFE is equal to angle, and now it was gamma, so that was angle E. What was that, D over the other side? Yeah, D. Why? Well, look, the proof is proof outlined above, I suppose. Proof above. Okay, so what do we have here? What we have now, with absolute certainty, if I just get rid of the alpha for a second, we now have that the right angles are the same, and we also have that beta is equal to gamma. So we know that 2 of the triangles angles are the same. It therefore follows that the third one has to be the same, because of course beta and the right angle add up to 180 when you add in that third angle. And so you have with gamma, which is the same as beta, and the right angle plus the extra one would be 180. Therefore those two things have to be the same. So really what you can just say, you can say that here, number 3, we can say that angle FAE is equal to angle, and it's the other one, which is ADE. ADE. And the reason is we just say the remaining angle in triangle. Okay, there you go. That's a proof. We've given reasons for all of these statements. That's really important as well. And of course, at the very end of every proof, you should just actually state it. You should say, therefore, it means that triangle AFE is similar to, it's about to write is congruent, is similar to triangle DAE. And of course, little QED in there as well. Okay, so that's how you should approach proofs. Okay, just statement and reason, statement and reason, statement and reason, therefore true, QED. Simple as that. If we have a look at our next one, which is to get the side A to D. Okay, get A to D. So that is, of course, following on from what we've just got. We know that they're similar triangles, means that their sides are in proportion. And what we want to do here very much is draw out 2 triangles. If you are using similar triangles or equiangular triangles, you want to draw out both things that you just got. Okay, so this is what we'll do. Just in here, label it as well, is what I would strongly suggest. A, E, F. Stick in a right angle here. We put in a double line there, and we were using a single line up there, and I think that's probably a good idea to stick with that. And then what you want to do is you want to get the exact same one, except, God, my drawing hasn't improved, except go and have the bigger triangle beside it. So again, make sure that it's marked. Which one's which? We know that A is down here, we know that E is here, we know that D is there. Why do we know that? That's our double one, which means that's our single one, just in terms of how we were notating it. Write in anything else that you know. You know that this is 12, you know that this is 5, you know a bit of Pythagoras' theorem is going to get you this other side, so that's going to be 13. That's just Pythagoras. I'm assuming that you can do that without a problem. Okay, anything else that we know? We know that A to E, which also comes up here, that's also 12. Okay, now if things are in proportion, just finally, what are we looking for? AD. Okay, we'll call that thing X. If things are in proportion, just do a small little sketch here. If we take a right angle triangle, if we say that's 3, that's 4, that's 5 in a right angle triangle, and if we stretch that same one, all the angles are the same, but we've just stretched it. If I told you that was 6, it would absolutely stand to reason that that had to be 8 and that had to be 10. If you stretch one of the sides to twice it, all the other ones will be twice it as well. So with that in mind, this is what you do. Start with the thing that you're looking for. We're looking for X. And you can very simply say that X compared to, and you just go to the other triangle and get the side which is relevant to it. So it's X compared to 13 is equal to, and then you pick another side that you know. We know 12 from the same triangle that X is in, and we compare it to the same side on the other one, or the corresponding side as they would say. So it is going to be 12 compared to 5. Okay, very simple equation. Multiply both sides by 13. X is equal to 13 times 12. 12 over 5. So let's just check what that is. So according to my calculator, that means that X, which is AD, is equal to 31.2. Do not forget to write in centimeters. Every time you forget to write in centimeters, well, centimeters up there, every time you forget to do that, you are losing 10 or 20%. You know, if it's out of 10, or if it's out of 5, you don't want to hand over marks that you don't have to. So there we go. Okay, that's that one. That is all junior cert stuff, but I appreciate that's a long time ago now. We'll look at next question. AFE, the triangle. So A to F to E. Okay, that's the one that we were dealing with, the small one. And A to G to B. A, G, B there. We're told that they're similar and show that AB is 36. Okay, so same trick again. Or a trick, but same approach again. Always a good idea to draw these out. AEF. We know that that's 12. We know that that's 5. We know that that's 13 by Pythagoras. And we were using a double for that, and that's there. Now, you'll notice, of course, that ABG, which was our other, or AGB, yep, which was our other one, it's orientated kind of like a mirror, so it's being flipped. So personally, I just unflip it, and you just gotta unflip it in your mind, really. So we'll have it maybe so that you can read the top thing there. So this is meant to be much bigger. We want A at the top again, okay, because that's our single one. We know that the right angle is where B is, if you check that out, and then G is going to be there. Do we know anything about these? We know something about from A to G. A to G, it's not just 27. Make sure that you read the question. A to G is therefore 39. It's our 27, 12. So AG is 39. And they're asking us to show that AB, always good to get the answer, AB, which is Y. Okay, so I think that you can actually see the triangle on the right is 3 times more. So I mean, you could instantly just say 12 multiplied by 3, but let's just do the same sort of layout that we did before. Start with a thing that you want. So you say Y compared to, and of course the corresponding side is 12, and the other one is equal to. Common mistakes that hopefully you won't be making is to say Y compared to 12 is 13 compared to 39, but that would be going from the big triangle to the small, and then small to the big. So you have to be consistent. We're going from Y to 12, that's big to small, and so it should be 39 to 12. It's just a small thing that sometimes people do, mainly in junior cert. I of course have written that down wrong. I was meant to say 39 compared to 13, sorry. So we have 12 times, and we have 39 over 13. And of course that's going to be 36, and I would say centimeters again, just to make sure that my examiner didn't take anything off me. Okay, find the area of the quadrilateral GCDE. Let's have a look at that. GCDE. Okay, so that's that stuff there. GCDE. That's everything inside there. Okay. let's see. We've got a few ways, I suppose, that we can go about this. Really, it's going to be about getting the area of a triangle and going from there. For this thing here, I might just mainly draw it in down here, and we can go along with that. Okay. Let's see. What do we know? We know that that's 12. That's 5. Okay. So there's a few bits and bobs that we learned along the way. One of them was that AD is 31.2. So let's put that in. So A to D is 31.2. Okay, we have to know that bit in there. What else did we find out? We found out that Y, which was A to B is 36. Okay, so that's the whole way along there is 36. Maybe I should write the 36 over there as well. Oh God, that's embarrassing. Let's just pretend I didn't do that. Okay. So that is what we're looking at there. Okay, so obvious things to do is get the area of the rectangle. Okay, length by width or height or whatever you want to call them. 36 times 31.2. So let's do that. Okay, that is an area of 1123.2. Couple of ways to the rest. I think did we get BG at one stage? No, we didn't get BG, but we know what BG is from over here. We know that this one is 3 times bigger, so of course BG is just 15. So we know that thing there is 15. We go from there. Okay, look, the thing that strikes me as the way to do this is to have a look at triangle ABG. Okay, that's that big side one there, and get that area there. So area of triangle, we'll call it triangle 1, is half the base times the perpendicular height. So that is going to be a base of 15, and perpendicular, got to be at right angles, is going to be that. So let's see, that is going to be 15 times 18, that is 270 centimeters squared. There's no need for centimeters squared until the very end. Okay, that's that one. You got a couple options here now that you can do for this one. One thing that you could do is you could just do a little bit of Pythagoras on triangle AED and find out what is D to E. Okay, so you could figure out what is D to E just by using Pythagoras. Therefore, you can use the formula. That would be fine. And in fact, that probably does seem like the way to do it. Okay, so what are we going to say? We're just going to say, running out of space here, that 12 squared plus x squared is equal to 31.2 squared. So x is equal to, let's just do that on there, 31.2 squared minus 12 squared is that, and it's going to be the square root of the answer. So it comes out as 144 over 5, or 28.8. That's what that is. So we'll get that second triangle. This is triangle now ADE. I'll get that area. We'll go with T2, and it's a half the base. This time the base I'm taking as 12. And the perpendicular height we just got, 28.8. 8.8. Lovely. So multiplied by 6, and it comes out that the second triangle is equal to 172.8. Okay, we've just got ABG, that triangle, and we've just got ADE. We're obviously going to add those two things together and take it away from 1, 1, 2, 3. So this is the area of the shaded region. It's going to be, let's just see here, 1,123.2. Obviously you do this in your box, but it's just a little bit trickier when it comes to doing it on a tablet. 27.8. So let's bash in all those numbers. say it's harder without you guys doing this and telling me how many times I go wrong in terms of adding. But there you go. This is what it should be. It looks to me like the area of the shaded region. And there you go. That's that question. And hopefully this has been useful. I'll stop it here. And I'll stick with another video soon, especially just talking about where we go from here. What's our plan over the next while? But look, that's for another time. Thanks.